All right, we're going to continue with 4.2, which is using the addition rule and multiplication rule for probabilities. So this first idea is talking about disjoint events. So remember, what an event is the outcome of something. Let's say if you're flipping a coin, there's two different events, or there's two different outcomes. You either land heads or tails. Event A is what you're actually trying to find. And event B is just describing another thing that you're trying to find the probability of. And the idea of them being disjoint is that they both can't happen at the same time. So if they occur, or they're called mutually exclusive, if they cannot occur at the exact same time. So events are disjoint that cannot occur at the same time. For example, let's say we're choosing numbers from 1 to 10. And let's say one event is you're trying to find the probability of randomly selecting an odd number. So that's either 2, 3, 5, 7, or 9. And then event B is trying to find the probability of randomly selecting a 6. The selected person cannot be both. So whatever you're randomly selecting, it's impossible to be both. You can't be an odd number and 6 at the same time. That's what it means to be disjoint, that the two events cannot happen at the exact same time. If you're asking yourself, well, what's the situation that would be, is if you're trying to find the probability of finding an even number, which I think that was on one of the tests. On the test, I talked about the probability of getting something of about an even number. But if one event is getting an even number and the other event is getting the number 6, that can happen at the exact same time. You can get an even number that is 6, because 6 is an even number. So now those two events are not disjoint. They're actually joint, meaning that they could happen at the exact same time. So when you're calculating probabilities, you have to watch out for those situations. So this is the first thing. Whenever you're calculating a probability, you want to decide if they're joint or disjoint, meaning can the event happen at the exact same time? And something that's not disjoint, again, so let's say you're randomly selecting someone to take a stats course. And then a second event is randomly selecting someone who is a female. This is not disjoint because there can be a female that's taking a stats class. So that means you're sort of double dipping or double counting that probability. So these would not be joint. These would not be disjoint. So you can either say not disjoint or just say that they're joint, meaning that both of these events can happen at the exact same time. Again, let's just say you're randomly selecting a student. That student could be taking a stats class, and that student can be a female at the exact same time. So in the previous example, you can't be an odd number and a 6 at the same time. You could be a female taking a stats class at the same time. So that's a joint event or not disjoint, where in this situation, it is disjoint because it can happen at the same time. The reason why it's important to determine if two events are joint or disjoint, and sometimes it could be 3 events or 4 events that you're talking about. But the idea is for the addition rule, which the big key thing to point out here is or. So wherever you see or, that's where you know to apply the addition rule. And you have to decide if the events are joint or disjoint. And the way you find an or probability is you find the probability of event A occurring and you add it with the probability of event B occurring. But if they happen to not be disjoint, meaning they are joint, you have to subtract by that overlapping part. So, for example, in this, let's say you're just randomly selecting a student in a stats class. Depending how many students you're talking about, you have to watch out for all the female students in stats classes. you're going to have to subtract that to each individual probability, because you're sort of double counting, because you can't pick that person different ways. Remember that idea about a simple event is that once you select in the stats class, if you select a female and taking stats, there's no other way you can select that person. They're going to be selected once. It's only one event. Just because they're in a stats class and they're female doesn't make them two different events. They're the same thing. That's why it would be joint. So you'd have to subtract by that. And sometimes they like to call that the intersection, meaning where these two events are occurring at the same time. So that's the probability. All you're doing is adding. If they're disjoint, so if there's like this example, let's say you're randomly selecting an odd number and you're choosing from 1 to 10. We know these two events are disjoint because you cannot be an odd or a 6 at the same time. So that means all I have to do is calculate the probability of getting an odd number and then add it with the probability of getting a 6. Let me show you that. So the one said randomly select an odd number from 1 to 10. So that means 1, 2, you have to like count how many. If you choose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's 10 numbers. So remember, your denominator is how many. What's all the total outcomes? So you can either land a 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 and a 10. But we're trying to find the probability of getting an odd number. And how many odd numbers are there between 1 through 10? There's 1, there's 3, there's 5, there's 7, and there's 9. So there's 5 odd numbers between 1 and 10. And I'm going to add that with the probability of the next event, which is randomly selecting a 6. Well, there's only one 6 between 1 through 10. Again, you cannot be a 6 or odd at the same time. So this would be the probability. If you're trying to find the probability of getting an odd number or 6. So again, these examples here didn't talk about or anything, but if you made this an example of trying to find the probability of event A or B happening, then we know they're disjoint, so you don't have to subtract by anything. All you'd have to do is add, which would just end up giving you 6 over 10. Because remember, when you're adding fractions, your denominators need to be the same. And once they're the same, you can just go ahead and add the numerators. So you have 6 over 10. And you should always remember, if you can simplify a fraction, you should. Because these both have a common factor of 2. So your probability would be 3 over 5. If you want to convert this to a decimal, which then converts it to a percent, you can. But that's just the idea of how, if they're disjoint, you don't have to subtract by anything. But if they were joint, for example, let's say you're trying to find the probability of getting an even number instead. Well, we know there's 5 even numbers between 1 and 10. That's going to be 2, 4, 6, 8, and 10. And then if you're trying to get the number 6, so again, it might look like the previous example, but this 5 is representing even numbers, where before it represented odd numbers. You have 1 over 10. But again, the idea is you're only selecting once. Let's say if you put numbers 1 through 10 out of a hat, you're just trying to find the probability of getting an even number or getting a 6. So you're only going to pull out of the hat once. You're only going to pick for a number once. You're not going to do one for event A and do another selection for event B. No, you're only selecting one number between 1 and 10. And then you're trying to find what's the probability of that number that you pick is an even number or a 6. The problem is here, one of these, remember when we talked about even numbers, 2, 4, 6, one of those is already in here. So that means we're sort of counting that probability twice. So that's where the subtraction comes in. I'd have to subtract by that over that intersection. That's where the two events happen at the exact same time. When which one of these is 6 and even at the same time, that can only happen one way. Because in between numbers 1 through 10, there's only one 6, and that's the only 6 that's even between 1 and 10. I mean, that's the only 6. That's not the only number, but that's the only 6 between 1 and 10, and it happens to be even. So I'd have to subtract by that. So you'd have to, these will end up canceling each other out, leaving you with a probability of 5 over 10, which is 1/2. And again, it's because half of the number are evens. So that's what the probability would be. If you're trying to find 6, that number is already accounted for. You don't have to count that twice. So that's what this is trying to show here. Oops, I went too fast. In this formula where it's talking about if you see or, you add the probability of event A happening plus the probability of B happening minus if there's an intersection. Meaning, is it possible for these two events to happen at the same time? And how many times can that happen? But let's do a couple more examples. And a very common example, of course, is using a deck of cards. And we're not using any jokers. And the way a deck of cards work, they start with A. For all other purposes, we're going to let A be considered 1. And we're going to go from there. We're going to assume A is 1. And then 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's a Jack, Queen, and King. So they all have that A, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Same thing here and same thing in this one. In case you've never seen a deck of cards. And then what also separates them is between color. So we have black and then half of them are red. But this half here are, I think you call them clovers. I think there's another word for them. But let's just call them a clover. And then there's spade, there's heart, and then there's diamond. So in diamond, they have an A all the way to king. In heart, you have A all the way to king. In spades, you have A all the way to king. In clovers, I forget, it's called something else, but I'm just going to call it clover for now. You have A to king. So keep that in mind when we're doing a couple of these examples. So again, this first one is asking, find the probability of event E, which is drawing a king. So out of those deck of 52 cards, you have to ask yourself, what's the probability of getting a king? So it's not saying it wants a particular number. It's not saying it wants a particular color. It's not describing heart, diamond, spade. It just says a king. And then we see here that there's 1, 2, 3, 4 kings. But the chances are you might get, if you're just selecting, if this card's in a deck, you're only going to pick one of these cards. It's a possibility you're going to get one of these. But you're just trying to find the probability of what it would be to get a king. So there's 4 kings in there. So when you're doing this, again, you have to do your probabilities. Your denominator is always all the possible outcomes. And there's 52 cards in this deck. And out of those 52 possibilities, remember the numerator is how many ways can event A, or in this case event E, happen. And we just saw that there could be 4 kings in a deck of 52 cards. So that would be the probability of randomly selecting a king out of a deck of 52 cards. But again, if you can simplify, you should. Because this is divisible by 4. So 4 goes into 4 once, 4 goes into 52 13 times. So that would be the probability of randomly selecting a king. Again, this one was more of an example. That first one was more of an example of what we did for 4.1. It was just your denominator is the total possible outcomes. Your numerator is the number of ways that event can happen, or the way it can occur. And this can happen 4 different ways. It could be a king of spades. It could be a king of clovers. It could be a king of hearts. It could be a king of diamonds. So those are 4 different ways it can happen. But you're choosing from a deck of 52 cards. Now the next one, we start seeing this OR in here. Same for the following one, we see this OR happening. And this is trying to find the probability of event E, means drawing a king, or F, drawing a queen, and then here's a third one, or drawing a jack. So for simplicity's sake, it only says A or B. But this could be A or B or C or D. You can do as many as you want. It's just you'd have to keep extending it. You'd have to find the probability of A plus the probability of B plus the probability of C plus the probability of D, and so on and so forth. But you'd have to subtract by the intersection of all of them. If that all those events can happen at the exact same time. So you want to be careful. But if we look at the question, you have to ask yourself, can the card, any of the king cards be a queen? And can any of the queen cards be a jack? And you see, here's my kings. It's not a queen and it's not a jack. Same thing, the jack cannot be a queen or a king, and the queen cannot be a jack or a king. It's just a queen. None of these cards can be another card at the same time. It can't be another number or letter. It could possibly be it could be a king of hearts. That can happen at the same time. But you can have a jack or a queen with a king at the exact. If you're only pulling one card out, you're just trying to find the probability of if that card is going to be a king or a jack or a queen. You can't just pull one card and then have a jack, queen, king all in that one card. It's only going to be one of those 3. So you have to ask yourself, is it possible for the king to be a queen or the jack to be a king, or vice versa all around? And they can't. That implies that they are disjoint. So when they are disjoint, I don't have to worry about this subtraction. All I have to worry is about adding each individual probability. So let's look at this. Well, we just did the probability of getting a king, which we saw that was 452. We're trying to find the probability of event E or event F or event G. And E was just drawing a king, F was drawing a queen, and G is drawing a jack. Since none of these cards can be none of these cards can be the same card at the exact same time, then they're disjoint, meaning all I have to do is find the probability of event E, which is drawing a king, plus the probability of event F, which is drawing a queen, plus the probability of event G, which is drawing a jack. Well, we just did the probability of drawing a king, and we know that gives us 4/52. But the probability of drawing a queen, well, again, how many cards are there? There's 52 cards, and out of those 52, how many of them are queens? Oops, there's 4 of them. Plus, again, out of 52 cards, how many of them are jacks? And it's also 4 of them. So now all I have to do is add the fractions. Since my denominators are all the same, I can just rewrite that 52. But I have to do 4 plus 4 plus 4, which gives me 12. Again, if you can simplify, you should always try to simplify. So again, we can simplify that 12 over 52, because 4 goes into 12 3 times, and 4 goes into 52 13 times. And if you want, you can use your calculator, but that's how you would calculate the probability of getting drawing a king, or drawing a queen, or drawing a jack. The main point is that they are all disjoint from each other. So all I have to do is find the probability of each individual one and add them all together. If they were overlapping at some point, I would have had to subtract by that additional part. Now here, this next example, I think you guys should be able to do. So find the probability of event A, which is drawing a heart, or drawing a diamond. Well, we have to look at how many of these cards are hearts. If I look back, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of these cards are hearts. And how many of them are diamonds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we know how many hearts and diamonds we have. Again, this isn't asking for a particular number or the letter. It's asking for just if I pull a card out of a deck, will that card be a heart or will it be a diamond? What's the probability of that? So we just calculated, we saw that there are 13 hearts. Let me just double check. So it's possibility of drawing a heart, which there's 13 hearts out of 52. And then again, can there be a card that's a heart and a diamond at the same time? No, hence they're disjoint. All I have to do is add these probabilities. So, and then a diamond is also 13 over 52, which this is going to give us 26 over 52, which is just 1/2. So that's the probability of drawing a heart or drawing a diamond. And that makes sense because 26 of those cards already is half the deck. So that means you're going to pick half of those cards are hearts and diamonds. So that's how we have our half here. We have hearts and we have diamonds, and that ends up making half of the deck. So there's a 50-50% chance that you're going to select a heart or a diamond from a deck of 52 cards. So those are those three. Here's a couple more examples. So this is choosing from numbers 1 through 10. So I would pause the videos and see if you can do these. Again, find the probability of event choosing an odd number or choosing 6. We did that at the beginning. You cannot be an odd or a 6 at the same time. So all you have to do is find the probability of selecting an odd number, which is 5 over 10, plus the probability of choosing 6. There's only one 6 between 1 through 10. So that was 1 over 10 was the probability of getting a 6. And we just added those probabilities together. Now you have to see, find the probability of event of choosing an even number or choosing an odd. Can you be odd and even at the exact same time? Think about it. Because again, you want to decide if they're disjoint or joint. And the third one, find the probability of event C choosing a prime number or event B choosing a 6. So pause the video here and see if you can do these, and we're going to do them together in a second. Okay, so we did the first one already, but now let's look at the second one. So find the property of choosing an even number or choosing an odd. So just like before, you want to ask yourself, are these joint or disjoint? Can the event be even and odd at the exact same time? And that can't happen. You either get an odd, so it's 5 out of 10, or you get an even, which is 5 out of 10. Which, when you add that together, you get 10 over 10, which is 1. So 100%. Because when you're choosing between these numbers, there's a 100% chance that you're going to get something. Because even numbers is half of those, and odd numbers is the other half. So that means you're going to get something. What that something is, you're not trying to find just when you're saying probability of even and then odd, you're essentially finding the probability of selecting a number when you pick out of a hat. You're going to get a number that's 100% true. So, and just keep in mind understanding what these mean. Well, the next one is asking, find the probability of event C, which is choosing a prime number, or event B, choosing a 6. Well, first we have to see, is there a prime number that's 6 at the same time? And no, the only prime numbers we have here, and prime starts at 2, so it's the number 2, 3, 5, and 7. 9 is not a prime number because 3 times 3 would give you 9. Remember, numbers that are prime are only divisible by 1 in itself. Meaning the only thing you can divide the number by is 1 in itself. So the only prime numbers between 1 and 10 is 2, 3, 5, and 7. So 2, 3, 5, and 7. So there's only 4. There's only 4 out of the 10 that are prime. Plus, because it's OR, and we're choosing 6. There's only 1 6 out of 10. And there's no intersection, so there's nothing I have to subtract. So I'm going to get 5 over 10, which is 1/2, which is the same thing as saying there's a 50% chance that when you're selecting from a number from a hat, numbers 1 through 10, there's a 50% chance you're going to choose a number. You're either going to choose a prime number or you're going to get the number 6. One of those two things might happen. Remember, or doesn't mean both have to happen, or just means one of them has to happen. For example, if your parents tell you, do you want to go to Disneyland or Six Flags? You're not going to both. You're only going to one of them. And means, what if you're going to Six Flags and Disneyland? That means you're going to both. That's the intersection. That means both events are happening at the same time. Or it's either one or the other. It's not both. It cannot be both. So let's continue. Pop this up. Hopefully you understood that. If not, please email me with questions or come to office hours as well. Here's a couple more examples. Again, try to pause the video and see if you can do these. Now we're looking at the first one. Since find the probability of event E, which is drawing a king or drawing a spade. So we go back. Well, we know 4 of these, out of all of these, 4 of them are king, but then you have to see how many of them are spades. So it's here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 are spades. And 4 of them are king. But we're going to do it right here. So yes, we know that a king, 4 out of the 52 are king plus 13 over 52. There's 13 spades out of 52. But we have to subtract by, well, you have to remember, you have to ask yourself, can one of these cards be a king of spades at the same time? And yes, there's one of these cards that's both a king and a spade at the exact same time. So we have to subtract by that 1 over 52, which will give us 4 plus 13 will give us 17, minus 1 will give us 16 over 52, which simplifies 4 over 13. Because 4 goes into 16 4 times, and 4 goes into 52 3 times. 13 times. Oops, let me move it up. And that would be our answer. Alright, the next one says, find the probability of event B, drawing a diamond or drawing a 10. Similarly, we know that there is 13 diamonds, and it's going to be the same. There's 4 10s, because there's 13 diamonds in a deck of 52, and there's 4 10s. And there's only one that's both a 10 and a diamond at the same time. So there's a 10 of diamonds. So that's the subtraction. And we're going to get the same answer again. The next question was, find the probability of event A, drawing a heart, or drawing C, drawing a card with an even number on it. Now, so again, one more time, find the probability of drawing a heart or drawing a card with an even number. So if we go back to a deck of 52 cards, so we'll read the question. So find the probability of event A, so drawing a heart or drawing a card with an even number. If we go back, we see here all these have a 2. These have a 2. These have a 2. These have a 2. And those have a 2. So we have 2, 4, 6, 8, and 10. So there's 5 from each. So 5 of these cards have an even number. 5 of these cards have an even. 5 of these have an even. And these 5 have an even. So that means when we're doing this last one, find the probability of drawing a heart. Well, we know there's 13 out of 52 hearts in a deck of 52. But plus, we have to draw a card. We have to find drawing a card with an even number. So let's do that. So we have drawing a heart. We know that's 13 out of 52. Plus, we have a card with an even number. And there's 5 cards that have an even number on them for each suit. So that's for the clover, for the spade, for the hearts, and for the diamonds. So 20 of the 52 cards have an even number on them. But then we have to subtract all the ones that double dip. So can the cards have a heart and an even number at the same time? And yes, it could be the 2 of hearts, 4 of hearts, 6 of hearts, 8 of hearts, and 10 of hearts. There's 5 of these cards that these two are overlap, because 5 of these cards in here have an even number of them, and 5 of these cards here have a heart. So it's already being counted for in one of these. You don't have to double count them. So it's 5 over 52, which will get 13 plus 20, we have our 33, but subtracting by 5, that's going to give us 28 over 52. Oops. Which you can definitely simplify this to 7 over 13, because 4 goes into 28 7 times, and 4 goes into 52 13 times. And that would be our answer for that question. All right, do one more problem. We'll do this. So it says, based on a journal article, the probability of randomly selecting someone who has sleptwalk is 0.292. So there's a 0.292 chance, or 29.2% chance, that you're going to select someone who can sleepwalk. So that's what that's saying. Probability of someone who sleepwalks is about 30% based on the data. So if a person is randomly selected, find the probability of getting someone who is not sleepwalked. Someone who has not sleepwalked. So remember, that idea of not has to introduce the complement. And I know I didn't write this. We didn't really have a formula for the complement, but remember, the complement is like this. When you're dealing with complement, you're doing the probability of the complement is equal to 1 minus the probability of the other. So this is the probability of getting someone that sleptwalk. This is the probability of someone that has not sleptwalk. It's just 1 minus the probability that has sleptwalk. So if you're trying to find the probability of getting someone who has not sleptwalked, it's going to give you 1 minus the probability of someone who actually has sleptwalked, because they're the complements of each other. One has sleptwalk, the complement is not sleptwalk, which will be 1 minus 0.292. And the difference here is going to give you what's the probability of someone who has not sleptwalked. So again, that's just an example of using the complement rule. It doesn't have an or, so it's just another example of looking at the complement rule. Other than that, I'm going to stop the video here. There is more to this, but I kind of want to break them apart so you guys see the idea of disjoint events and joint events, and looking at or the addition rule, because we're also going to look at the multiplication rule, but I want to do that in a separate video. So hopefully this helps. I'm not going to put homework in this one. I'll put homework in the next video, so just watch out for that. Other than that, thank you. Have a good day.